Week 2, lesson 2. So I have given you two different equations of lines in two different forms, right? So here's one line and here's another line. And we're trying to find the point of intersection. You've done this before with systems of equations, but we're going to go ahead and try and do this with these different forms of lines and vector forms, right? And there's a lot of different forms. So for example, for R, if I rewrite this using some column vectors and this parameter lambda, it would look like this. All right, and again, you can pause and make sure you understand where that came from. Likewise, this equation is supposed to be Cartesian form, but it's not exactly right. The y has to come first. Those are not considered to be interchangeable in Cartesian form. All right, so if I take the first equation and I write it in parametric form, then I have sort of equations for each x and for y. X would be 2 minus lambda, and y is negative 5 plus 3 lambda. All right, and then I can go ahead and make a substitution into this Cartesian form. So 2 minus lambda plus 2 over 3 is going to equal negative 5 plus 3 lambda minus 1 over negative 1. Let's do a little bit of housekeeping, combining some like terms. 3 lambda minus 6 over negative 1. And then I will cross multiply and get lambda minus 4 equals 9 lambda minus 18. And if I solve this for lambda, I should get, 14 equals 8 lambda, or lambda equals 7/4. Okay, now that doesn't give me a point of intersection, right? That just tells me what lambda is. But if you look over here, I can plug those lambdas, or that lambda, singular, into each equation and figure out what x and y are. So if I plug them in, I get x equals 1/4. I also get y equals 1/4. All right, and I'll let you guys, break out your calculators, plug that number in, make sure you get those answers, okay? Don't just trust me. All right, next. In this particular example, you've been given 3 lines, right, in different forms, right? All 3 of them different forms. I've got Cartesian form, I've got standard form, excuse me, and I've got vector equation form. And we're trying to figure out if they are concurrent, meaning do they all intersect in one point? So what I'm going to do is I'm going to find the point of intersection of lines 1 and 2. Right? I'm going to figure out where these two intersect. And then once I know where that is, I'm going to see if that is on the third line. Because if it is, that's where they intersect. Okay, so here we go. Line 1 is, I'm just going to cross multiply it. 3x minus 3 equal to 2y plus 2, which is, in other words, 3x minus 2y equals 5, which I'm going to substitute in. Actually, I'm looking at it. I know you can't see me looking at it, but just trust me that I'm looking at it. I see a 2y right here in line 2. So I'm going to actually solve this one for 2y. 3x minus 5 equals 2y, and substitute that into line 2. So I'm going to have 3x plus 3x minus 5 equals negative 3, or 6x equals 2, or, sorry, I got to move this up a little bit, or x equals 1/3. Okay, and if I plug x equals 1/3, into either one of these, I should be able to figure out what y is, all right? Which, again, is going to be the point of intersection. I know the x part, but I need the y part. So I've got 1/3, and when I plug it in, I get a y of negative 2. All right, so now the question is this on line 3? Because if it's not, then there's no way that they intersect at that point. So let me find line number 3. It is right here. Okay, I'm going to rewrite that in vector form. So negative 5, 6 plus lambda times 2 over negative 3. All right, and since My ordered pair down here is an x and a y. I'm going to substitute that in. 1/3 -2. And I'm seeing if that is equal, that's a plus, to this. Let me clean that up a little. Sorry about that, guys. Okay, so there's two equations right there. Let me, in fact, I'll highlight them so you can see the two different equations. There's the top line versus the bottom line, two separate equations. Okay, so let me write the top one in red. I have 1/3 equals -5 plus 2 lambda, which if I solve becomes 16/3 equals 2 lambda, or lambda equals 8/3. And then if I solve the second one, which is -2 equal to 6 minus 3 lambda, which is -8 equals -3 lambda, lambda equals 8/3. Because these are the same, that means all three lines are concurrent. All right? It means that I got the exact same parameter when I used this ordered pair. All right, and I know it doesn't look like an ordered pair, it is a vector, but we're just trying to make sure that that ordered pair actually exists on that line. Scooting it up some more. Okay, so this time we're trying to show that this, my dog is snoring right next to me. I don't know if it's picking up on the microphone, but that's my dog Bowie. Anyway, okay, so now we're trying to show that this point D does not lie on this line. Okay, so again, I'm going to take that line, I'm going to rewrite it in vector form. X, Y, Z. Here's my ordered pair of 1, 2, 0 plus lambda times my direction vector of -1, 3, 2. Again, feel free to pause and really look at the equation that's given and how you change that into this form. Okay, it's really important that you're able to do that. Because now I'm going to take this ordered triple, I'm going to place it here. 1, 2, -3 equal to 1, 2, 0 plus lambda times -1, 3, 2. And I'm going to solve all three equations. There are three. 1, 2, 3. I need to solve all three of them and see if I get the same lambda. So let's do the top one in red. 1 is equal to 1 minus lambda, or lambda equals 0. The second one down in blue, 2 equals 2 plus 3 lambda, 3 lambda equals 0, lambda equals 0. This is looking good. And then the last one in green, -3 is equal to 0 plus 2 lambda, but this one, lambda is equal to -3/2. So because I don't get the same lambda all three times, it does not lie. So I have shown it because of this. All right, and then lastly, let's find the vector equation of the line parallel to this. So parallel to this, but that passes through this point. So let me take line L and rewrite it in a different form. That's my other dog, Crusher, sneezing. I don't know if that's picking up on the microphone. -1, 3, 2. Okay, so here's my direction vector, right? If you think about what a vector equation is, it's a starting point and a direction to go. So I know the direction that I want to go, and I have a new starting point. So here's going to be my answer in red. X, Y, Z. My starting point is at 1, 2, -3, and my direction is the same as this one, -1, 3, 2.